Hello everyone, welcome back to another video. As always, if you enjoy the content, make sure to leave a like and subscribe. So in this video, this is going to be part 2 of explaining options and giving you a tutorial. And so what I'm going to be doing in this video is going over the Greeks and how exactly they fluctuate option prices. So when you open up the options chain, you see all these numbers and the Greeks right here: delta, gamma, theta, vega, and rho. And if you guys are new to options, you probably don't know what exactly they mean, but hopefully by the end of this video you have a better understanding of what they are and how they affect option prices. So the way I am going to structure this is I'm going to start by explaining the most important to the least important. And the very first two are kind of tied because they're in my opinion the two most important Greeks. But I have to start somewhere, so the first one I'm going to explain is delta. So what is delta? So delta, the exact financial definition of delta is ratio that compares the change in price of an asset to its derivative. But in basic English and terms that you will understand much easier, it basically just means how much is how much is the option price going to change in value for every $1 that the stock moves. So every day the stock is moving up and down, and so you want to be able to track how much an option price is going to change in comparison to the stock that it's deriving from. So let's go ahead and get into an example. So let's say, we have a call option, right? And if you guys don't know what a call option, I suggest you guys go ahead and look at my previous video. Link is down in the description. But let's say we have a call option, right? And the initial price of the call option is $5. And let's say that this specific call option has a delta of 25. And so that means that for every dollar that the stock moves up or down, the call option is either going to move up $25 or down $25. So let's say the stock price increases by $1. And so that means that our option price is going to increase by a delta of 25 because it's going up. So that means that our new option price would be 525. However, if the stock price decreases by $2, we would be losing money on the call option because the way you make money on a call option is when the stock goes up. But like I said, if the stock goes down $2, that means that we are down 50 cents on the option, which is the delta times 2. That gives us 0.50. So now let's go ahead and explain this put. So let's say we have a put and it cost us $3, and the delta for this put is 0.30 or negative 0.30. Delta for puts is always negative, so that's why you see the negative. So let's say in this case the stock price increases by $1. So why did we have the value of the put go down right here? So if you guys remember from last video, the way you make money on a put is when the stock price decreases. So it makes sense that if the stock price is increasing, you're losing money. So that's why here, when the stock increased by $1, you're down 30 cents on the option. On the other hand, when the stock decreased by $2, you're up 30 cents. Actually, that should say 3.60, not 3.30, but you get what I'm trying to say. So when the stock decreased by $2, this is going to change the delta, and now this should be $3.60. And so that's basically what delta is. So now the next trick that I'm going to explain, which I think is the two most important ones, is theta. So the exact financial definition of theta is the measure of the rate of decline in the value of an option due to the passage of time. But in other words, like, you want to summarize that down, that's basically just time decay. And I'm pretty sure you guys have heard many people talk about time decay and how an option value decreases over time. And this is basically what they're talking about when they mention time decay. They're just talking about theta. So now let's go ahead and get into some examples. So let's say right here we have a call option and the initial price of the call option is $5, right? And the theta for calls and puts is always negative because option prices always decrease as time passes by. So let's go ahead and explain this. So let's say for this call option, we have a theta of negative 30. And so after one day, assuming that nothing else affects the call option, we would be left with a option that costs $4.70, which is 5 minus $30. Now, after 5 days, we would be left with the option price that costs $3.50 because 30 times 5 is the difference between these two. And as you guys can see, as time passes by, the prices of options are just going to continuously decrease. And it's the same thing with put options. In this case, we have a $10 put, a theta of negative 50. And I should mention that the higher price the option is, the higher theta is going to be because the options are designed to basically go all the way to zero upon expiration. So that's why they have a higher theta. So in this case, after one day, we'd be left with the option that costs $9.50. After 5 days, we'd be left with an option that costs $7.50. So this one's pretty easy to understand. Just theta is how much an option price is going to decrease per day due to time decay. Nothing really to it. Now, the next two are a little bit more complicated, but they're not super hard to understand. So the next one we're going to explain is gamma. So what is gamma? Gamma is the rate of change in an option's delta per 1 point move in the underlying asset's price. That's a mouthful, and that might be a little bit intimidating to understand, but essentially what it's trying to say is how much is the delta going to change every time the stock moves up or down. And so if you guys remember, in options, there's things called in the money and out of the money. And so basically what you want to think about is the option that you have getting further in the money, or is it getting further out of the money? And so now let's go ahead into the explanation and examples. So let's say we have a call option and the initial delta is 0.60. And so if you guys remember what I said earlier on in the video, that means that for every dollar that the stock moves up or down, the call option is going to move up or down by $60. And so let's say that we have a gamma of 0.10. So that means that in this case, new delta, let's say the delta increases by $1. So because this is a call option and every time it increases, it's going in our favor, that means that it's moving further into the money. So that means that the delta is also going to increase, which means that after a $1 increase, our new delta would be $70. Let's say we have the same call option, but our delta decreases by $1, which means the stock decreased by $1. So now we would be left with a delta of 0.50. So now let's go ahead and say we had a put, right? So the initial delta is 0.40. And the gamma is 0.15 on this one. So when the delta increases by $1, that means that the stock option, or that the price of the stock increased by $1. So that also means that the position is moving against us, because when we have a put, we want the stock to go down. But since it went up, that means we're actually losing money. So it's moving further out of the money. So that also means that this initial 0.40 delta is going to move down to negative 0.25. However, let's say the new delta decreased by $1, and that means that the stock price decreased by $1. So now the delta is going to go up, and it's going to move from 0.40 all the way to 0.55. So the next Greek is Vega. And what Vega is, measurement of an option's price sensitivity to changes in the implied volatility of the underlying asset. So basically what that means is how much is the option price going to change if implied volatility increases or decreases by 1%. So as I mentioned in the previous video explaining options, I said that option volatility is always changing. You should follow the VIX to kind of get a sense of whether implied volatility is rising or dropping. But overall, implied volatility plays a pretty big part in option pricing. So let's go ahead into the example. Let's say that we have an initial option price of $15 here, and say the Vega is 0.35. So that means that for every 1% implied volatility increase or decrease, the price of an option is going to increase or decrease by 0.35. So let's say that the implied volatility increases in 1%. And usually every time implied volatility increases, that's in your favor and it's going to make the option price increase. And that is why from right here, we went from an initial price of $15 up to $15.35. But on the other hand, let's say that this implied volatility dropped 3%. So instead of having an option price being 15, we now have it at $13.95, and that's because the implied volatility dropped. Let's go ahead through another example. So let's say we have another option at $10.50, and this time the Vega is 0.15. So every time the implied volatility goes up by 1%, that means that the change in our option price is going to move up by 15 cents. Until same thing right here, right here it dropped 3%. So that means that we're going to decrease the initial option price by 3 times 15, and we would be left with an option price that is equivalent of $10.05. So, you can think of Vega as the IV crush, that gets thrown around a lot every time earning plays comes in, because usually every time after earnings, the IV tends to drop a lot, and that's when Vega would come into effect pretty fast, because you get a sense of how fast the stock price is going to change. But that's pretty much it for Vega. So the last Greek that I'm going to talk about, and the one that is really not used at all, is called rho. So what rho is, it's the measurement of sensitivity of an option or options portfolio to a change in interest rates. And so the reason why rho isn't really taken into account for is because for the most part interest rates are relatively stable. We are not changing interest rates even right now during a pandemic. When we do change them, it's usually less than 1% increments. And so this is why rho is really not going to play into an effect as to how options are priced. But if we did somehow get a sharp rapid increase or decrease in interest rates, then it would play a part in. So let's just say the way rho is measured, it's measured in 1% increments. So let's say the interest rates rise by 20%, which would probably never happen, but let's just say it did. So that just means that the option prices would increase not by 20%, but by $20 each. So every time the interest rates increase, then the option prices would increase, and vice versa. When interest rates decrease, the option price would decrease. But like I said, interest rates are usually relatively stable, which means that for the most part, rho is not going to have a big effect on the option prices. So that's pretty much it for this video. I hope you guys enjoyed this video, and if you guys have any other questions about what the Greeks are or more examples, just leave a question down in the comments, or you can also join my Discord chat and ask me there. Thank you guys for watching, and I will see you guys in the next one.